To conclude, I'll summarize the key takeaways, the practical applications, the limitations, and the future directions. First, we have key takeaways. Pre-workout caffeine was associated with lower session RPE during a realistic 4-day upper/lower split. The perceptual effect also appeared consistent across upper and lower body sessions. In other words, when caffeine was used, participants generally rated the workout as feeling easier overall, and that pattern looked similar on both training days. Moving into practical applications, the first point is that training may feel more manageable. Lower session RPE may support effort and consistency on demanding days. Even a small reduction in perceived effort can matter, because perception often influences whether someone completes a session as planned and whether they feel confident coming back. Excuse me, coming back for the next workout. Second, caffeine can be used strategically. Rather than taking it before every workout, it may make more sense to consider caffeine before high volume or heavy sessions, or before key workouts where you want to maintain training quality. This can be especially helpful when a session is likely to feel challenging due to the workload, time constraints, or accumulated fatigue. Third, there may be a potential benefit for adherence. Lower perceived strain may help maintain a training routine during periods of stress, low sleep, or busy schedules. When life demands are high, workouts often feel harder. So if caffeine helps reduce perceived difficulty, it may support consistency and reduce the likelihood of skipping sessions. At the same time, caffeine should be individualized and used safely. Response varies based on tolerance, habitual intake, and sensitivity. And there are practical side effects to watch for, including jitteriness or anxiety, gastrointestinal upset, and elevated heart rate. Sleep disruption is also a major concern, so avoiding late day use is important because poor sleep can undermine recovery and performance. Now on to limitations. First, the sample size was relatively small, which limited generalizability. Second, we use a fixed order, no caffeine first and caffeine, caffeine second, so learning or familiarity effects may contribute to lower RPA later in the week, independent of caffeine. Third, dose habitual intake were not tightly standardized, which can create a variable individual responses. And finally, RPE is subjective, and if this applies to our study, objective performance metrics were limited, meaning we can't fully determine whether perception changed alone or alongside performance. For future direction, stronger design should include randomized, placebo-controlled, double-blind procedures. Dosing should be standardized using milligrams per kilogram, and habitual caffeine use should be assessed. It will also be valuable to add objective outcomes like volume load, reps completed, or bar velocity alongside session RPE to better understand how caffeine affects both perception and performance. In conclusion, this study examined whether pre-workout caffeine changes how hard a resistance training session feels, measured by 1 to 10 session RPE at the end of each workout. Using standardized 4-day upper-lower split, where participants completed 2 sessions without caffeine followed by 2 with caffeine and served as their control. Bottom line, caffeine may be a practical tool to reduce perceived effort for some lifters when used appropriately and safely, but the findings should be interpreted cautiously given the study's fixed order, design, and other limitations.